Hello Internet, I'm Guy. I've been self-employed almost my entire adult life, and I've had multiple serial and parallel careers. One of those parallel careers is my art career. And yes, you may be wondering, what the heck am I showing pictures of down here in this video? These are my Digital Numeric Relevator artworks, and I've been making them since the 1980s. I've made 32 of them so far. These works and many of my other works have exhibited all over the world, throughout the US in museums and galleries, in Japan, Canada, and England. I've had a modestly successful career, to be honest. And so I continue to make these pieces. What is a relevator, you may ask? Well, the purpose of a relevator is to satirize the implicit trust that we have whenever we see an electronically represented number. I'm talking about gas pumps, calculators, those kinds of things where there's an intrinsic display that only is formatted to show numbers. So my relevators are designed to show irrelevant numerical information as a direct attempt to satirize that trust that we have whenever we see one of these things. It's inconceivable that we would look at a calculator and it would be wrong. It's almost never happened. So my role as an artist is to kind of wake people up to things like that, and I think it's fun. So my pieces are playful, they're goofy, and they're irreverent and irrelevant. That's the whole point. This video that you're watching here shows a whole number of them starting from the early 80s all the way up to into the 2000s, and I'll link to it in the description below. So today I'm making number 33 in my series. Join me on my journey. So here's a quick preview of the piece that I'm making today. As you can see, it's showing red and green and blue numbers, and they respond to ambient light. So the numbers get smaller when the light gets darker, and that's a really great randomization feature, and I'm all about randomness with these pieces. This particular piece was inspired by these small digital voltmeters that I found on a surplus electronics site. And they can measure anything from, very low voltage, like 3 volts up to 36 volts, I believe. So what I've done is I've mounted a little tiny photocell right here onto the device and put a little tiny resistor on there too. There's a little resistor right here. And the point of that is to create a resistor divider. What photocells do is they change their resistance in response to ambient brightness, light striking the cell. So what this does is creates a voltage divider that changes a voltage in direct relationship to the ambient light. Let me turn them on so you can see this. There's 3 of them hooked up. So now if I cover up the photocell, you see the voltage plummets. This is a voltage reading, but it might as well be a reading of ambient light. What I like about this is it creates completely random numbers, and I've actually taken the little tiny set screw on the back here and misadjusted them deliberately so that they will be completely randomized. So what I'm going to be doing now is mounting them in a grid, because I've got 9 of them, 3 red, 3 green, 3 blue. Mounting them up to these little tiny standoffs here, so I'm putting little nuts on right here, and then I'm going to make a little assembly like that and make a product that looks a little like a sharper image product from the Twilight Zone is one of the ways I've described my work. So let's jump in. I'm going to do a little machining on the mill to get a series of holes gridded out to mount these, and then I'll make an acrylic case for them. I've marked off some grid lines here on a sheet of black acrylic that has the paper backing on it, and I'm starting my first drill hole at my 0, 0 position on my digital readout. And now I'm just going to move over to the next spot, and I've got all the numbers calculated on a notepad down below so I can see where I'm going. These are the first 2 holes for the bolt holes for those little displays. So I'm getting this one set up. And proceeding through the first line here. These are just the mounting holes, and then I'm going to come in later and now drill the holes for the wire that goes through to the back. There's a 1/4 inch hole. There's the last one. The paper is always interesting to peel off. Depending on how old or how long the acrylic has been sitting around, it takes more work to peel it off. This is a counter bore. I wanted to deburr the edges of the holes so the wire can dress through those holes fairly easily and not snag on them. So I'm going to do both sides of this panel. Now I'm going to sand it with some 220 orbital sandpaper here on the orbital sander. And the reason for that is to create a matte finish there on the acrylic. This piece, it turns out I was thinking it would be visible, and it's not. It's actually ultimately going to be hidden inside the piece. But this is something I've done all along, is to create a matte finish on acrylic. I think it makes it look more interesting. So I'm going to take the wire here and shove it through the holes, and then bolt each part down. I've got all the red ones on the left. Now I'm testing this one to make sure it's blue. The blue will go on the right. There they all are mounted. This is the snake pit on the back that is going to get organized. So I'm going to cut all these wires down and then tie them off to these copper strips that I'm going to stick down. I'm going to basically make the equivalent of a circuit board. Circuit boards are called PC boards because they're made of plastic and copper. And so here I am with a sheet of plastic and a bunch of copper, and I'm essentially making a PC board. This is just a way to dress all the power leads into each of the displays. This is the last horizontal bus bar, is the technical term for this, where it feeds the power across horizontally. Then I'm going to bring in some vertical lines shortly to connect the odds and the evens to the pluses and minuses. So I'm just cutting off the excess lengths here right now. So this one is the bus connector that will be for all the positive wires, and then the negative one is the closest one to us. Now I'm cutting them all down to length. And using my wire stripper to get in there and just strip off a little piece at the end. That wire stripper will strip several wires at one pass, and these are all, of course, pairs of wires here. So now I'm bridging the copper with some solder here to make sure that the columns and rows are all interconnected. So I'm using my meter to check continuity to make sure all my solder joints are good, and so all the plus wiring and all the ground wiring are all interconnected. So far so good. So now I'm going to tin all these little wires with a little solder. Tinning is a reference to the fact that solder contains mostly tin, and so it's an old-fashioned term relating to solder. Nowadays I'm using lead-free solder, that is using mostly antimony, I believe. So I'm going to hold those down, solder them in, and so I'm connecting all of the grounds to those top rows and all of the pluses to the bottom rows. It's a little fiddly to get these wires held in place, but once I do, it doesn't take long to melt the solder and just tag them down. So there they all are. So now I'm tinning the bottom edge there of the positive bus bar and attaching a red wire to that and a black wire to the negative bus bar. This is where the power will feed into all of the displays. So now I'm going to hook up some power and make sure everything's working. And yes, yes it does. Look at that. All those numbers, they're so cool and pretty, aren't they? Looking at these things gives me a big happy. I just love numbers and colors and bright lights and reds and greens and blues.
Hello again. I hope you're enjoying my video. If you are, please give me a like or a super like. And you can support me on Patreon if you would like. And don't forget, if you haven't already subscribed, please do, and then you can hit the notification bell so you'll know when I'm releasing another video. I can really use your support. These videos take me about a day to produce.
So now I need to bring in power to a power jack in the back. So this is the back panel, which will be an opaque black piece of acrylic, and again it's covered in paper. It makes it a lot easier to mark off things and so forth. So this is the back panel. I'm going to peel off this paper, which is, this particular sheet of acrylic is about 2 or 3 years old, so the acrylic is just coming off. If it was any older than that, it would be much harder to get off. I'm using Brillianize here, which is a wonderful acrylic cleaner that leaves a really nice sort of clean, shiny finish. So this will be the back panel, and I'm going to now glue that to the entire assembled case that I've built. The gluing process uses this little tiny syringe filled with basically a solvent that welds acrylic, so that basically it seeps in by capillary action between the two surfaces and welds the two surfaces together very quickly. I'm only going to hold that for maybe 20 seconds or so, and then it's done. So now you can see the inside wiring that I've already done. I've added a few components to it to get it all to fit there, and that's just sliding in like works in a drawer. There are holes on the left and right side that will secure that in, and that is the power jack that will fit in there just fine. These edges now need to be trimmed off, so I'm going to go over to the router here and do a flush trim with the bearing follower there. So these edges are now all flush. One final pass there. Now I'm going to sand the whole box. I've decided the whole thing needs to be a matte finish rather than glossy. There's kind of a track record I've done of that. It creates almost like a chalkboard finish. And again, I'm using the Brillianize to create a beautiful finish on there, get rid of the sanding dust, and make it look like it's a finished product. My goal is to make these things look like they're actual products. I want that veracity, that verisimilitude of a real product appearance. I was originally thinking of leaving the front shiny and clear, and then I later decided to sand that too. This is the power jack. I'm just going to hook the wires onto that. It's a little challenging to do it by hand holding. I think I lost connection on that black wire there, so I have to go back and get that. It's really fussy to hold these things. I should have put it in a clamp or something. But there we go. Got it. So now I'm going to connect the wire from the circuit board to the wire sticking out from the power jack there. And I have a couple of pieces of heat shrink tubing on the wire beneath my hand, and I'm going to slide up over those connections. There we go. I don't want them to short out to anything else inside the box here. Bring in my heat gun and melt down those heat shrink tubing sections. And now those solder joints are fully protected. So now everything will slide in there, and then I've got some flathead screws that will go in and secure the electronics drawer component inside. First test, I'm going to plug in the power supply. Plug it in, turn it on, and first reveal with the matte surface that I sanded onto the front face there. I really like the look of that. You see a lot of products these days that do that. You see when I put my finger over where the photocell is, or if I shadow it, the numbers go down, and they're just wiggling all over the place, and they're just so random. I love that. So now I'm working on the base. I wanted to have a little wider base as a support for it. So this is a sheet of 3/8 inch acrylic. Notice I've labeled it black cast and the date that I purchased it. It gives me a sense of how easy the paper covering is to remove. Putting a little bevel on the top edge here. Kind of a chocolate bar kind of a finish there. There you go, you see the bevel. This is a relatively recent piece of acrylic. Again, I think it was 2019, so that paper comes off pretty easily. If it was a few more years older, it would be really hard to take off. And there's actually a special material, a spray-on, that you can spray onto the paper that will help it come off. So again, sanding everything matte and using my very old bottle of Brillianize. Had that around for 20 or 30 years. So now I just need to mark off the holes in the base to line them up with the holes that I've already made in the bottom up here. You see where I'm lining it up to the ruler there. They're exactly 4 inches apart. So I'm just setting up the lines for those holes. And of course they're a little bit offset from center. I'm going to put a couple of number 6 flathead screws in there. So I'm going to recess those flatheads in there. There we go. Check to make sure they'll go in. Oh, I'm going to peel off that paper first, yeah. Screw those in. And voila, it is a finished sculpture. So here it is, working. I'm going to plug it in the back, and there it is, doing its thing. Generating irrelevant numerical information for your pleasure. The working title for this piece is Digital Numeric Relevator Mark 33 Light Approximation.